welcome here on stage. Thank you for being here at SFSCon 2025. I know you have a presentation and we are curious to listen to the results of the research. Thank you.
Well, thank you for the introduction. Okay, so it's one of the final presentations of the day. I know you're tired. I'll try to be as concise as possible. So, yeah, this presentation is about, So a research paper, the Software Transparency Foundation published in these last months is about correlation with between LLM-generated code and open source software. So the agenda is a quick introduction on the topic, then a few words on the Software Transparency Foundation and its relationship with ScanOSS, and then we'll go to the research, the results, and we'll have a few of key takeaways, right? So, it's clear that developers love AI coding assistants, but legal teams may not like them so much. And why is that? Because it's, I think, undeniable at this point that AI-assisted coding enhances speed, productivity, and so much more. But what are the risks that come with AI code assistants? So the reality that we are facing is that developers are reusing code at a precedented speed without them knowing sometimes. And Gen AI kind of accelerates this, so you have that synergy going on, which is a problem because when you use Gen AI for coding, it actually hides provenance, so ownership data and attribution data is sometimes lost, right? Thus, you expose your organization, your company, or your own to reputational risk, compliance risk, and security risk. So, I want to talk a little bit about legacy software composition analysis tools and technologies really briefly. Now, basically to detect Gen AI OSS or code that's licensed when reusing or using AI, you need snippet level scanning. So using dependency manifests is not longer enough because developers are not just reusing libraries and components, but even small snippets. So they might be programming, coding, and asking an AI assistant for a particular solution to a function, let's say, and there might just be 3 lines of code, but that might be OSS, right? So on the Software Transparency Foundation now, so real brief, this foundation, of which ScanOSS is a strategic member, has the mission of solving software supply chain transparency. So the transparency gap that we just mentioned, the foundation is trying to actually solve this issue, right? So for that, it gives access to an open source knowledge base, almost 16 terabytes in size, so pretty large, of only just source code lines. And yeah, it offers it as a free service, accessible through an open API, which is also really cool. And yep, so now on the research, which is the important part. So we basically, ScanOSS and the foundation try to do a study on the percentage of actual LLM-generated code that had OSS in it, right? Because there's not so much reference on that, and we need the facts to actually back up our claims. So the only prior research that we found on this topic was done by a Chinese team of developers that basically evaluated a few LLMs on a sample data set of less than 1 terabyte, so not so much as the OSSKB. And they found non-negligible, so basically 0.8, I think, yeah, 0.8 to 2% of OSS into LLM-generated code. And additionally, most LLMs actually fail to provide accurate license information and for copyleft components specifically, right? So this was all the prior research that we had, which is really not so useful. But we did things a little bit differently in our study. So we used a data set that's almost 35 times larger in size. We also, this data set was composed of many different projects, not just a few, so close to 250 million projects were in this data set. And the matching of LLM code to open source was done using snippet level matching instead of a method that this Chinese team developed, right? Which was basically grabbing the metadata of a function and removing the body and asking the LLM to regenerate that implementation. So going on the setup of the research, the study basically grabbed 10,000 code snippets generated with LLMs, and they scanned it with the free service I mentioned. And, well, that's kind of something I forgot to explain, but the matching isn't done using source code lines, so it's done using hashes, which is more accurate and fast. And the metrics used to basically compare the similarity were the same as the Chinese research, besides the last one, which is a match ratio that the technologies that OSSKB uses can take basically advantage on. So snippet level matching instead of just implementation. The results. So let's go a little bit back. So in the previous research, basically they found 0.8 to 2.2% of OSS code into LLM-generated code. And in our study, we found that 30% of AI-generated code contained at least 10% of OSS. So that's a lot. And what our conclusion was that it's related to the size of a data set. So if we were to add more open source to the data sample that we use for comparing, it will probably be much larger. So if 0.8 to 2.2 was enough to worry, 30% I think it's more serious, right? So a few key takeaways. So we need to take LLM AI generated code as OSS because 30% is the most expensive Russian roulette you can play in the world. So you may be getting licensed software into your own code base, which is dangerous, as we just saw. And basically a call to action. So AI makes SCA obligatory, I think, and snippet level SCA more important than ever because people are just not reusing libraries and components, but even snippets, which is, I think, the big differentiator here. And with that, a small quote. So if AI writes your code, you are still responsible for its license. So don't forget that. And we're done. I promised.
Thank you, Jeronimo, for your presentation. Is there any question? Yes, there is one there behind.
Thank you. I wanted to ask you, there is a problem with a mathematically perfect solution as code. So if a repo has this code mathematically coded perfect, I can still reach this code by myself. So is still plagiarism?
So, I mean, that case I think is pretty specific if it's leaked like by mistake, right? That's what you said, or?
It's not leaked by mistake. It's just the same solution.
Okay.
Because it's mathematically.
So a generic solution, let's say, something that's like objective, right?
Or just a function which does this thing.
I mean, it all depends. It's a process. So after detecting the software, you can make your decision. So with generic code, I mean, there can be like sample configuration code from like certain tool in your software, and you are not doing plagiarism. So if I copy a sample web server configuration, I'm not doing anything wrong, right? But you can take decisions once you know that your code is open source or from another person, not before. So you need the detection first. Then the decisions are like your decisions. So yeah, the important part, I think, is detection here.
Okay, thank you.
No, thank you.
Thank you. Is there any other question? Yes, there is one. Here in the second row.
My question is if you suggest a particular practice or suggest to organization, to companies, how to, after this analysis, how to move, no? To take care about this warning.
Yeah, I mean, so software composition analysis, which is this, should be a part of the development workflow. So at some point in time, you need to know your composition. So most companies do it in an automated way, so during CI/CD. So yeah, it's, I mean, with building on what others have presented today, there's a lot of regulations incoming also. And yeah, I think it's more important than ever, probably.
Thank you. Any other? Otherwise, I have one that may be a little lateral with respect to that research, but hopefully it's connected. Have you ever thought about the connection between the generation via AI of a text, not only software programming, but also general communication text, such the one that are used in scientific publication? I'm a journalist, so I'm thinking also about articles.
Yeah, sure.
Because the connection between plagiarism and generating things via AI can be quite strong.
Yeah, I mean, I haven't explored that particular subject, but what I can really like draw, I think something that AI code or AI generated stuff shares is that these models are being trained with material. So in case of open source, it's being trained most probably with open source software. And it may be also trained with, I don't know, news articles, right? So I think there's a good point in saying that AI is trained to basically regurgitate the things that have been fed to him, right?
Okay. So the risk is present,
I mean,
and maybe need to be
probably
quantified somehow.
Yeah. I'm not an expert on that one, but
yeah, but yeah, thank you very much.
No.